Like the thing that we did in class today, we're going to split it up into groups. I feel like it's probably a better way, right? Alright, so let's begin this. So we're going to do rate calculations, rates. And that's a very good start, matter of fact. Define a rate. What do you think rate is? When you see the word rate, what does that remind you of? Or what pops up in your head when you see that? When you hear the word or see the word rate, R-A? Matter of fact, you should write that. Rate. Your own definition. What is your own definition of rate? So, what's your definition of rate? Perception. Oh, nice definition. What do you mean? What does that mean? Let's say you explain to someone who has never taken algebra or math. What is rate? Break it down even further. What do you think? You don't have to write this down. What do you think rate is? Oh, the rating system. Oh, gotcha. Okay, gotcha. And rate can also be speed, right? Distance. Or I'm going at a rate of 2 miles an hour. How long will it take me to travel 10 miles? Right? So rates, that's one of them. So this is what we'll do. So we definitely, so the standard is calculate rates using approximate units, right? Appropriate units, I'm sorry. What about when the word unit comes up in math or in life? What does that remind you of unit? Okay, so let's write that down. Alright, so we got units, right? So I guess the purpose of these assignments that we're doing is we worked on the past solving the math. And I think we didn't go in depth with actually understanding the scenarios and understanding word problems, right? You struggle with word problems. You're really good if I give you just 10 times 10. But if I put some words around it and put some variables around it, you get confused, right? So this is what we're going to do. So right now, again, repetition, rate is, unit is. Good. If we can chunk them together, let's say rate and unit, what scenario would pop up in your mind straight? If I tell you, Stanley, we're doing problems that consist of rates and units, what pops up in your mind right away? Math, rate and unit. Equations, exactly. Exactly. No, that's exactly what it is. So rate and unit, the problem we'll focus on today, I'll do the first one. So we'll implement this process. I do something, we do it together, and then you do it by yourself. I do, we do, you do. Right? So if we look at the first one, we have a student spent 15 minutes painting a 2 foot by 3 foot bulletin board. Correct? to the nearest tenth of a minute, how long did it take the student to paint 1 square foot? There's a lot of English in there, right? So let's say I'm a student right now, I'm reading this. So this is my own problem. I'm reading this. Student spends 15 minutes painting a 2 foot by 3 foot bulletin board. I can picture that it's like a rectangle shape or something, right? It's not a square. The square's side's got to be all equal. Here's a rectangle, and this is where it gets interesting. To the nearest tenth of a minute. What is that? To the nearest tenth. I'm thinking this right now, right? I'm thinking to myself. And then how long did it take the student to paint 1 square foot? So without even doing any math, there's first English to dissect, right? A lot of vocabulary. So to me, this tell me if you agree with me or not. I think one thing that I have to understand in order to solve this problem is, what does this mean? 2 foot by 3 foot. That's not normal English, right? We don't say that in everyday life, 2 foot by 3 foot. That has to be something that's counted as units, right? So 2 foot by 3 foot. Where in life will you encounter 2 foot by 3 foot or 100 foot by 50 feet? Construction site. So I think of Home Depot. Like let's say I go to Home Depot and I'm like, listen, I want to buy wood. I want to buy wood that's 2 feet by 3 feet. Right? It's a construction site to build something. That's a really good. That's real life examples that we're thinking about. Anything else that might? Condo? You mean housing? So like the room is your room is like 20 feet by 30 feet, something like that, right? So exactly. So real life scenarios is foot by foot means measurements of measurements in units of foot of a certain object. Could be wood, could be a bulletin board, could be a room in a condo, correct? Alright, so I understand that. The next one, which is the trick part, to the nearest tenth of a minute. I'm thinking, okay, tenth of a minute. So how many minutes are there in an hour? 60, right? And they want near tenth of a minute. But the first thing that pops into my mind is, do they want tenths of an hour? Like we're doing tenths of a minute. What if it's a minute? Do they want 10 minutes? Or if it's 15 minutes, do they want 20 minutes? But I quickly realized to the nearest tenth of a minute means if it's a minute and 50 seconds, let's say 1 minute and 50 seconds, right? We round that up to 2 minutes. If it's like 6 minutes and 2 seconds, we round that down to 6 minutes, correct? You with me? Alright. So let's say I run a mile in 6 minutes and 2 seconds, right? Somebody's like round that to the nearest 10. I'll round it to 6 minutes. And remember, everything under a 5 we round down, everything up to 5 we round up. So if I run a mile in 6 minutes and 47 seconds, I'll round it up to 6 minutes and 50 seconds. 47 becomes 50, right? No, so let's picture this. So this is the part, right? So let's do this together. I did that, so let's do this together right now. Alright, so let's dissect this problem. First, let's start writing that there's a painting. He spent 15 minutes painting a 2 foot by 3 foot, right? So just write 2 foot by 3 foot painting took 15 minutes. Alright, so we got that. 2 foot by 3 foot, right? So we're doing this together, and now we're going to say that to the nearest tenth of a minute. So we're converting our dots from foot by foot to now time, right? See, this says 2 foot by 3 feet, right? Now we're not even thinking about feet, we're thinking about time, right? Minute. So you already know there's 60 minutes an hour, and each minute has 60 seconds, right? And to round it to the nearest tenth, what does this vocabulary mean to you? Nearest tenth of a minute. I'm going to give you 3 examples, 3 times, and you're going to round them to the nearest 10, alright? So write the first one down. Let's say the first one is 1 minute and 37 seconds. The following one is 15 minutes and 21 seconds. And the final one may be just 56 seconds. Round these to the nearest 10. Let's do the first one together, right? 1 minute and 37 seconds. So what's the 10th here? Is the minute a 10, the 3 a 10, or the 7 a 10? Exactly. So does the 3 remain? So there's only 2 options here, right? Either we can convert it to a minute and 30 seconds, or a minute and 40. But you have a 7 there. What are you leaning towards right now? Exactly, that's the answer. So write down 1 minute and 40 seconds. Can you do the second one? 5 minutes, 15 minutes, and 21 seconds. So what are the 2 options that you have? Correct. Grandma's going to be happy. What about the next one? 56 seconds. What does that become? 60 seconds. 60 seconds is also known as a minute. Exactly. Alright, so we got that out the way, right? So if it takes 15 minutes to paint a 2-foot by 3-foot bulletin board, how long to paint 1 square foot, right? So the math involved in this is so 2 by 3 foot, right? What is that? How many feet are there in that bulletin board? So this board, let's say this is the bulletin board, right? This is 2 feet and this is 3 feet, right? How many feet are there in total? To get that, we must do 2 times 3, right? Length times width equals area. Remember that? Correct. So the inside, how much is space inside the bulletin board, right? So we already know this side is 2 and this side is 3, but how much space do we have inside? To do that, we must do 2 times 3. All right, so that's your first procedure in the problem. Which equals 2 times 3. And now, you have 6 feet, right? And it takes you 15 minutes to paint all 6 feet. How do you come up with how long does it take for 1 foot to paint? So 15 minutes to paint 6 total feet, right? How long will it take you to paint 1 foot? So what's the mathematical procedure? You already have the time and the area, right? But now you want to find some one instead of 6. So you have 6 feet, but you want to find 1 foot. So the best thing to do here is do 15 divided by 6, because it took you 15 minutes in general, right? The entire thing took you 15, and you covered 6 square foot, 6 square feet, right? That's what you covered. So you're going to do 15 divided by 6, and that's going to give you your time for 1 square. Exactly. Okay. So what's 15 divided by 6? Let's do log division. Do 15 divided by 6. How many times is 6 go into 15? Yes, it definitely goes into 6 times 1 is 6. 6 times 2 is 12. It goes to 12. 2. 2. Yeah. Long division in a while, right? So write the 12 underneath the 15. What's 15 take away 12? 3. The 6 go into 3? No. Right? So you'll write 2 point on the top. So 2 point. So whenever you put a point in division, that means the next variable you gotta add a 0 to it. So add a 0 to the 30. It becomes a 30. How many times does 6 go into 30? Let's do this. What's 6 times 1? 6 times 2. 6 times 3. 4. 5. There you go. So that's how long it takes you to paint 1 foot, right? 2.5. The answer says round it to the nearest 10. So you literally have 2.5. Can you round it any further? So that's your final. Circle the answer choice. Pretty good, right? Alright, so we're gonna keep going. This, let me turn this off.